Alright, so this is my example of how to do a non-standard maximization problem. Just like any normal simplex problem, you're going to start with a set of equations, but I'm going to start off by showing you the initial matrix you get from those equations. And here it is. And like any normal actually, this is where the difference starts between a non-standard maximization and a normal maximization. In a normal maximization, these numbers over here, where are they? Here, are going to be positive, but unfortunately they aren't for this one, so we're going to have to change that around a little bit. What you're going to do is you're going to divide this top row of numbers by this bottom row. Pretty simple. Actually, sorry, excuse me. This bottom row is going to be divided by the top row. And here's what you get. And what you're going to do is take the highest number and that's going to be your pivot number. Now, I don't know if I explained this in the last video, but you're going to take it from your set of negative numbers up here. So this is -1, -1, -1. That's the set you're going to use. Okay, so now since you know that's your pivot, like in all these other ones, you're going to switch x3 and s1. This is going to stay x3, but this is s1 is going to become x3. So here are your functions that you're going to want to perform in order to get that. Most of them pretty simple. And here is our next matrix. And as you can see, this is now 1 and everything else is zeroed out. So once again, you're going to want to take now it's actually just like a normal maximization problem, where you now have a negative number, but we have to change that again to find our pivot row, and that's here. Our pivot column, our pivot row is going to be 3 because we have a division by 0, -100, you can't use negative numbers, so the only other number left to use is this one, and we're going to use that with 3. So here is what you're going to do to this matrix. Basically, again, you're just going to want to make this a 1, and you're going to make all the rest of them 0. And here are your functions that you're going to want to perform. And again, you're going to want to perform those across the entire row to make this 0, this 1, excuse me, and the rest of them 0. Here's your matrix. After that, we still have a negative number, so we still have to keep going, and you want to use your most negative number, which is going to be -9. So, once again, you're going to find out that this is your pivot column. You're going to take division of all of these by all of these, and here's what you're going to get. And once again, we have a division by 0 and a negative number, so once again, this is the only number that we can use. So we're going to once again make this 1, make the rest of them 0. And here are your functions. They're going to provide that. And here's our matrix. And once again, it's pretty simple. Just 1 zeroed out, drag across. Now, as you can see, we no longer have any negative numbers here. So we're very close to being done. We don't have to change anything. We don't have to create a new matrix. What we have to do now is make sure that the rows and columns match up. So x3 and x3 are going to have to be 1, where that means it's going to have to be 1. It is already. Where S1 and S1 meet is going to have to be 1. And where Z and Z meet is going to have to be 1. So here's what your final is going to look like. And I didn't write this down because I'm pretty sure all of them are just divided by 3. Yeah, x3, x3, you're going to divide that whole row by 3. S1, S1, all divided by 3. And Z, Z is all going to be divided by 3. And here is going to be your final matrix. These ones are pretty simple. You're just going to take across to this end column. Here is what you're going to get. So x3 is going to be 116 2/3. x2 is going to be 166 2/3. Your max z is going to be 966 2/3. And the rest, because they aren't in this column, are all going to equal 0. And that's your basic rundown of how to do a non-standard maximization problem.